Okay, hello Cloud Gurus. How y'all doing? Welcome to the lab on data storage. We're going to do some air quality analysis. In our introduction, I talked about a way that you could choose your own adventure with these labs, and I'll get to that in a second. But I just wanted to revisit it here and let you know that you have different paths you can take. But first, let's look at our problem. So we currently work for a US-based nonprofit organization that promotes better environmental conditions in communities that most need it. And currently, our organization is preparing a campaign around awareness of ozone as an environmental pollutant. So we've been asked to identify the top regions in the US with the highest average ozone levels. And we're going to use that information to help target a social media awareness campaign. Let's break down that problem space. So first, we're going to have to find an open source data repository for air quality readings. And next, when we have that data, we're going to have to figure out which services would be appropriate for us to be able to query that data or analyze that data. And finally, we have to answer a very specific question. What city had the highest average ozone reading on October 9th, 2018? And we're going to need that answer for the quiz at the end of this chapter. So if you are going to choose the expert path, this is your stop. This is where you pause the video and you go out and try to build this thing. And then when you're done, you can come back and see how I did it and compare notes. If you go any further, spoiler alert, I'm going to give you some hints that may make it a little bit easier. All right, it seems like you've chosen the intermediate level, which is perfectly fine. The next slide is going to show you some hints which may help you get started. As far as an open source data repository, the hint I'm going to give you here is registry.opendata.aws. And regarding AWS service and tools that work well with big data of that type, just wanted to remind you that Athena works really well against JSON files. And for the question about which city had the highest average ozone, you're still going to have to find that by analyzing the data yourself. So if you're intermediate, this is where you pause now and go see if you can create it. If you keep watching, we're going to go into the walkthrough and I'm going to take you through my solution for this problem. So if you took the expert path, maybe you came across this. It's a registry of open data on AWS. And among the entries they have here is something called OpenAQ. It's a data source that is stored out on S3 and we can access it. In fact, you can use this URL to access it, and it has a little browser built into it. And because the question that we've been asked to answer pertains only to one day, we're only going to focus on one day's data. So I can go to the console, and then I'm going to start AWS Glue. I'm going to use a crawler to discover the data and create a schema for us. Now I put in the S3 bucket where that data lives. And I'm focusing just on the day that we need to really minimize our data set. I do have to create an IAM role here. And now I can add my database. So I'm going to call my database OpenAQ. Okay, now I can run the crawler. And now that it's stopped, we can see one table has been added. So it's crawled through that directory and aggregated all those files, those JSON files, into a table. And we have 300,000 rows in this table. And here's our schema. Now I can go over to Athena and start working with this table. So we can see the data that's in the table now. And it contains data from a lot of different countries and a lot of different locations around the world. But I'm only interested in the US, and we'll take care of that a little bit later. But first, one of the things that we can also do is we can generate the DDL to recreate this table. And you can see it defines our schema up top. And then it also talks about the output format and input format, and you can see Hadoop is used. And then our location of our S3 files. So just to demonstrate here, I'm going to copy this and I'm going to paste it into the new query to show you that we can just create a new table just straight from DDL. I'm going to change the name because I don't really like that name. So I run the query and the table is created. I can delete the old table, which I'm going to do. Now, as I said, I'm really only interested in the US data on ozone. So I'm going to create a view here that will restrict us just to the perimeter 03 and the country as US. And I'm also breaking out latitude and longitude, as well as converting a date into a timestamp. So once I execute that query, it creates the view, and we can look at some of the data inside the view now. Now, just from this right here, we could probably figure out the answer to the question. We could just use a select max or something like that. But I wanted to go ahead and demonstrate using QuickSight to help with some visualizations. So first we have to subscribe to QuickSight, and then we have to go out and set up our permissions. Now there's a bit of a trick here. You have to select both Athena and S3 and select the S3 buckets that Athena is set up to use. We also have to add the OpenAQ bucket because we're actually going out there and dynamically selecting from that data. So now we have our permissions set up for Athena and our S3 buckets. And we can go back and create a data set. So we're going to select Athena as our data set, and we can give it a name. Then it's going to ask us to select our database and our table or view. In this case, I'm selecting the view. And I'm going to choose to load this data into Spice, which is an in-memory cache that QuickSight offers, and it really speeds up queries. So you're going to see that it's importing right now, and then eventually you're going to see on the right-hand side, the little window is going to show how many rows were imported. In the meantime, I'm going to change the name here. There we have 100% success and 21,000 rows were imported. So QuickSight's very visual, it's very drag and drop. So I can drop a measure and then a dimension, and it's going to produce a chart here which has a lot of different entries. You can see it has the you can see this chart has all the entries. And to make things a little bit more manageable, I think I want to apply a filter. And I'm going to add a filter for any city that is greater than 0.04 parts per million. There. Now you can see here's the city with the highest ozone to Larry. You're going to need that for the quiz. Now let's create something else. Another nice feature of QuickSight is that it does geospatial analysis. So we can use our latitude and longitude to plot on a map the locations of these cities. Now, by default, filters only apply to one visualization. And in a bit here, I'm going to go and apply that filter to all visualizations. So now we can see on a map very visually what areas of the country have the highest average ozone readings, at least on this day.